Today we're going to be doing operations with imaginary numbers. And so when we're dealing with operations and imaginary numbers, today we are going to focus on multiplying, adding, and subtracting. It works very similar to whenever we're working with x's. So when we have multiplying with binomials or multiplying with a coefficient, it's all the same idea. We're just take it just one step farther. When you have I times I, it becomes I squared. What is I squared? -1. And so we'll replace any of our I squares with -1. Does that make sense? And so that's one of the biggest things that's going to change. When we're combining like terms, does our exponent change on our variable? So if I have 3x plus 4x, we end up with 7x, right? So if we are adding and subtracting, the number does not change. The exponent does not change. Complex numbers is another way to say that we're working with the imaginary numbers. When you're working with complex numbers, they typically will write it to where they put them in parentheses because each of these represent a complex number. The real part is the part that doesn't have an I on it. The imaginary part is the part with the I. So there's a real and imaginary part to every complex number. So we have 3i minus 2 plus 4i plus the quantity of 6 minus 2i. I am going to show you through several different steps. You do not have to write every step, but I want to have it to where it's not hidden what's being done. So step 1 is we need to distribute this negative sign to both parts, or that minus sign to both parts, and this plus sign to both parts. And so that 3i just hangs out in the front. And then we're going to take that minus, and we're going to distribute it to the positive 2. And that minus, and we're going to distribute it to the positive 4i. Same thing on this next one. We're going to take that plus sign, and we're going to distribute it to the 6. And that plus sign, we're going to go with the negative 2i. You don't have to write it where the signs are combined and shown this way. I'm just showing where they came from. So these two signs create what? A negative. What do these two signs create?
Positive.
A negative. A plus and a minus create a negative, just like a minus and a plus. So it's the opposite signs that creates the negative. If they match, they create the positive. So now let's look through and combine like terms. So negative 2 plus 6 is what?
4.
Positive 4. Positive 3i minus 4i minus 2 is, or minus 2i, excuse me. So positive 3 minus 4 is what? Negative 1. Minus 1, or minus 2, negative 3i. That is your answer. So the first step is to get your signs taken care of, then combine like terms. Same as you've done since junior high. Just now our variable is the imaginary number I. Let's do it again. So I'm first going to distribute these signs. So we have 4i minus the quantity of 3 minus 2i plus the quantity of negative 5 minus 10i. And so those distribute. And so that 4i gets written down minus a positive 3 minus a negative 2i. Plus a negative 5 plus a negative 10i. Now we're going to change our signs so we know what they are. This time we have 3 signs that need to change. Negative and a negative make a positive and a negative make a. And so we're going to combine our parts. You have a negative 3 minus 5, making it a negative 8. You have a 4i plus 2i, creating 6i, minus 10i, negative 4i. So that's your answer. Yes. Your real part comes first, your imaginary part comes second. Especially those that are going up to college algebra, it gets more stickler. The professors typically are more picky about how the format is. And same thing with pre-cal, because pre-cal there's parts we're going to be going into where that's important to have the order. I'm going to give you a little bit of forgiveness in Algebra 2, meaning I'm not going to count it off completely wrong. So the other operation we have is multiplication. You can use FOIL, or we can use the box to multiply in. So when we're factoring, we take and go out. When we're multiplying, we go inside. FOIL works just the same. And so we are going to write on the outside of the box the negative 2 plus 5i and 4 minus 3i. And we're going to multiply in. No, you can use FOIL. If you like FOIL better, it works the same. And so let's find our real parts. So that's going to be the part negative 2 times 4 is what? Negative 2 times a negative 3i is going to give us 5i times 4 gives us 20i. Now, when we have 5i times a negative 3i, that gives us a negative 15i squared. What is I squared? Negative 1. So negative 15 times negative 1 is that real or imaginary? That's real because there's no I involved. So that goes with the real parts. So over here I have negative 8 plus 15. plus 6i plus 20i. And I just take what's in my box and write it down where it's together. If you want to just use your box and do your math in your box without going over to the other paper and writing it down, that's fine. But if you need to have it seen to where you have it all grouped together, that's one way of doing it. So negative 8 plus 15 is 6 plus 20. And the I hangs out with it. That's the answer. So when we're multiplying these, or just this straightforward, sometimes there is something in front. Oops. So this time we have a negative 1, or a negative in front of the parenthesis, which is a negative 1. 2 minus 3i, that quantity squared. That's the same thing as me writing 2 minus 3i times 2 minus 3i. And I'm going to let this negative sign hang out in the front until I'm ready to work with it. It's hanging out in the front until we're done with the FOIL process. You could distribute it to the first parenthesis at this point, but I don't like to deal with it till the end whenever it has them in the front. And so the 2, negative 3i, 2, negative 3i in both spots. So our real parts. 2 times 2 is the imaginary. 2 times negative 3i. Negative 3i times 2 is negative 6i again. Negative 3 times negative 3 is 9. I times I is I squared. You don't have to show this work down here at the bottom every single time. You're going to get to where you know what that process is. So 9 times negative 1, negative 9. So this is negative 9. That negative 1 is just hanging out till we're done. The real parts are 4 minus 9 and negative 6i minus 6i. So that negative sign is just hanging out. 4 minus 9 is, and negative 6 minus a negative 6, or minus 6, excuse me, negative 12i. That negative sign, all it's going to do is create it to where it changes the signs. And so we end up with the answer being 5 plus 12i. And I'm going to do one more example. This one caused a lot of people with problems in the first period, so I'm going to go ahead and work through one similar to it. So if I give you negative 2i and 3i and 2 plus 7i, what do you do first? Combined like term is typically said whenever you're adding and subtracting. Can we add or subtract to combined like terms? Are you thinking about, is this what you're thinking about, is combining these two? So multiplying the two monomials together. So what is negative 2i times 3i? Negative 6i squared times 2 plus 7i. What is I squared? It's a negative 1. So negative 6 times a negative 1 is going to create a positive 6 out front. 2 plus 7i. How can I solve this? Distribute. So 6 times 2 is?
12.
Plus 6 times 7 is? Don't overcomplicate this problem.